Hi everyone. What I'm going to be doing is running a regression and correlation and showing you how to interpret the output. We run regression correlation when we have two interval ratio variables that we are interested in relating to one another. Let's say the variable I'm interested in looking at is TV hours viewed per week, and I'm curious to see whether people who work more watch less TV. So my hypothesis is going to be the more you work, the less time you have for TV. The two variables I'm going to look at are hours worked last week and TV hours viewed daily. The first step is to create a scatter plot. Since TV hours is my dependent variable, I'm going to put it in the y-axis. And since hours worked last week is my independent variable, I'm going to put it in my x-axis. Here's my scatter plot. And the trick to reading a SPSS output of a scatter plot is to try to see if there's some type of directionality going on. And it does somewhat look like as we increase a number of hours worked last week, we see lower and lower numbers on the Y variable, hours per day watched TV. So if you notice, let's compare those who work less than 40 hours. Right? If you see, they're kind of clustered all over the place. We have people watching 10 hours of TV, 15 hours of TV over here, 20, 25 hours over here. Those who work more than 40 hours a week, you don't see that among this group. Nobody watches more than 10 hours a week in this group that works over 40 hours. So this is suggesting a negative relationship that as people work more, they tend to watch less TV. The next step after creating a scatter plot is to create a correlation. So what we're going to do is go to Analyze, Correlate Bivariate. I'm going to put my two variables in here. This is my correlations table, and it's basically a crosstab. We have our independent variable, number of hours worked last week, and then we have hours per day watching TV. So when we correlate to the two, pay attention to the Pearson's R, Pearson's correlation, and remember that R tells us two things. It tells us the strength, and it tells us the directionality. Our R is negative 0.140. So that's telling us that there is definitely a negative relationship, and we're going to need to look at our chart from the PowerPoint to determine the strength. So if we look at the chart that is available in the PowerPoint slideshow, it's telling us that anything between -1 and -2 is a weak negative association. So we have a weak negative association. The other thing to look at is whether or not you see two stars next to your Pearson's R. So the two stars next to the Pearson's R tell us that our correlation is significant at the 0.01 level. So we also want to provide our p-value, which is provided here, significance. In this case, our p would be less than 0.001. The other thing you're required to do is to square the Pearson's R so that we can get R squared. And R squared tells us the predictive power of x. So here's our calculator. We're going to square negative 0.14. And we get 0.0196. We can multiply this by 100 and we get 1.96. So our R squared is 0.0196, and what it tells us is that x explains 1.96% of the variation in y. The next step and final step is to create the regression table. So to do that, we'll go to Analyze, Regression, and Linear. Our independent variable is hours, 1, and our dependent variable is TV hours. Okay, so this last one is our regression table, or our coefficients table. And so where it says unstandardized coefficients, that's what we're going to pay attention to. Under the column B, those are the coefficients that we're familiar with. Where it says constant, it's speaking of the y-axis, so 3.25 is our y-axis. We can start our regression equation here and state that our regression equation will be a plus b times x, where x is any given value for the independent variable. So what we have is predicted y equals, a is our y-intercept, so 3.25, and our slope is negative 0.019. Okay, and so we can interpret this by saying that for every unit of x that we increase, we will decrease our predicted y by negative 0.019.